Today, I'm mainly going to briefly introduce one of our 8 features and give a demo. First, the background is about the CSI driver that we are using. Now, when the driver uses FS, we can only use the code control command to essentially create a pod and perform some debugging operations. But first of all, the operation of pod control is quite cumbersome. Some novices, especially those who are not familiar with FS, are not very friendly. The second is the relationship between port-mark port and PV/PVC storage class in the process of using JuiceFS. Well, it's complicated. No. If you don't know much about the entire FS architecture, the entire usage process is still not smooth. The last one is about the debug operation. The troubleshooting process is also very difficult. We usually need to find your application pod and then find the PV corresponding to the PVC used by the application pod, and then find it. It corresponds to the mount pod and then troubleshoot the entire operation process. You need to have a deep understanding of K8s, Git, and the architecture of the JuiceFS CSI Driver. Otherwise, the troubleshooting process can be quite difficult, especially as the number of your application ports increases. And when there are many PVCs and PVs in the cluster, for example, dozens, hundreds, or even thousands. This troubleshooting operation using code control will become more difficult. So we developed a dashboard which uses a graphical interface to simplify the entire troubleshooting process for everyone. This is a background introduction. And next, I will introduce the CSI Driver dashboard from the aspects of installation and usage. First, regarding installation, we can follow the installation documentation on our official website, and we highly recommend using Helm for the installation. It's actually very simple, just a few Helm operations. You can refer to this document when you're using it. Now, when we actually use it, I have a prepared balance point YAML file that we need to set up ourselves when installing with Helm. This contains all the configuration information used by our CC driver. We can take a quick look at several configurations related to the shell dashboard. Here, it is enabled by default, and then you can set it. In HamChat, set its login account and password, and then here you can configure its usage resources. Generally speaking, you can use the default configuration. There's not much else that requires extra attention for the other configurations, and we'll introduce the other features one by one as we go along. Here we use a Helm upgrade command, which is also directly available in this document. You can just run this command to get it started, and then we can see that under the system section, it has already the installed components include several for the CSI, one of which is the CSI controller, deployed in a step facet format. The dashboard has just one deployment with a default replica count of 2. I have only installed one here, and there's also the CSI node. These 3 components, once deployed and ready, mean that all components of the CCI Java are ready for use. All right, once it's deployed, another key point is how we can access this dashboard. It's important to note that since the dashboard is a graphical interface, how can we access it effectively and efficiently in this particular scenario? I think this step is quite crucial in itself, especially for beginners, as they often get stuck here. We have about 4 ways to access the dashboard. And the first one is by using the FS console. Is available if you've purchased our enterprise version, and there's a private deployment console. If that's the case, I can go to the settings page. Under the settings, there's an option for reverse proxy. We can fill in a field to set up a reverse proxy to the CC driver through this console, and then we can access the CSI driver dashboard through the console. This is where you set its path. You can just fill this in casually. And here you need to enter the access path for the CSI dashboard. You can check the CSI dashboard's service, SVC, and use its IP or just view it directly like this. You can access this CCI through its cluster API, which corresponds to port 8288. We'll just reconfigure it a bit. Of course, the premise is that your control and CSI driver need to be accessible. So the proxy rule here can be written like this, right? And there's a default prompt after saving it. There's a shortcut for project 2 here. You can just click on it to access our console. So the CCI dashboard is one way to access it, but if you haven't installed our CCI or the CFS control, you can also use K8s. Some more native access methods. The first one is to forward the port of the CSI dashboard service and run it directly. This command means to map the 8088 port of the dashboard SVC to the local 8281 port, which is also relatively fast. Once this port is forwarded, the seal cannot be turned off, so we can access the dashboard directly at 127.0.0.1 on port 8081. This is one method. Then there are two more. One is to use the service's notepad to map the service's port to the node. And first, you need to turn it off. Now, we can take a look over inside. Under the dashboard, in the services section, you can change the type to notepad. By default, it's set to cluster IP, but you can also change the service port here. After changing it to not port, you can reinstall it and then you'll be able to see it. The SVC is set to notepad and you can access it through the corresponding node's public IP, which is mapped to port 8288. This is one way to do it. Right, this is one way to do it, but I haven't mapped the machine's port here, so I won't demonstrate that. Another option is ingress. There's an ingress under the dashboard service, and it's turned off by default, but I've enabled it here. But the prerequisite for using ingress is you need to deploy an ingress controller in your cluster. Here is a default rule that we provide. You can also add a host, which you can define yourself. After the deployment is complete, you can see it. Under the Kube control system, there's an ingress resource. If your ingress controller is configured properly, then under this ingress, you'll find the FS CSI dashboard in English. The status can provide you with an accessible LB address. If you've configured a host, you can also set up some host rules locally to access it using your domain name. I don't have a domain name here, so I directly use the port of this LB to access your B's IP, which is also a way of access. Yes, there are 4 ways of access, and this is the way we access here. We'll demonstrate using the simplest method, which is to open it in a portfolio format. Once you do that, you can see it clearly. So that covers how to access the dashboard. We've introduced 4 methods. Next, let's talk about how we can use the dashboard for quick debugging. First, let me introduce this dashboard page. On the application port page, it will only list all the pods using FSPUC. If your application isn't starting up. If there's an issue, there's a small red warning icon at the end of the application port chain. When you hover your mouse over it, a simple tooltip will show you the current status. For example, if the node has a problem, you can click in to check its events or logs. For example, if the mount pod corresponding to it isn't starting up and there's an error, it will show that your mount point is not ready. So this is the APP application page. Here, on the APP application page, it lists the corresponding mount port, which is associated with it. This way, you can clearly see which APP application corresponds to which mount port, and there are links available that you can click on. The second part is about configuring the system components of our system. This includes CSI, various components of CCI, including the CSI controller, the CCI dashboard, and the mount pod are here as well. If there's an issue with the mount pod, there's a simple prompt here, and we can click in to take a look at it. Why isn't the mount pod starting up? This is the detail page for the mount pod. Here, it displays its basic information, including its name. You can see its namespace and status. And you can click to view the complete list of containers associated with it. Generally, a mount port only has one container, which is called mount. Using this mount port for the APP port. Here, you can directly connect to the corresponding CSI node of this mount pod to check its status, ITO, and events. How do we troubleshoot this? You can check the logs. But if you can't figure it out from the logs, usually you can see why it isn't starting up. If that still doesn't help, you can look at the node's recognition. For CESO, you generally want to check the logs of the JuiceFS plugin container centralized. Here, you can see that it was forced to shut down Topaz because it didn't start up within 60 seconds. This is the CSI node's issue. There are also all the PVs of PVFS. If this PV is not functioning properly, it will also show a simple troubleshooting direction. Here it doesn't have a corresponding PVC. This is the PVC list. You can filter it, you can filter by DM for the namespace, and there's also a list for the storage class. There's also a type called EA, which is the category home. This is the FS operator we have, which supports the creation of the commercial version of CFS. We have made an operator to help you better manage distributed environment clusters on K8s. I'll introduce this separately in a bit. There are also two pages. One is the config page, where you can modify our global configuration, and the other is the batch smooth upgrade page. This is a simple introduction to the functionalities of the dashboard. Let's take a closer look at how we can manage the mount pod on the dashboard. We can perform the following operations on the dashboard. One is to view the logs. Then, inside its container, you can exec into the container to run some troubleshooting commands, collect FS access log files, gather debug info, and also execute or map as a cache warm-up and for smooth upgrades. Let's find a live dashboard. After clicking on the details of the mount pod, we can see an action on the right side of the container list. This action supports several operations. There are several icons, and when we hover the mouse over them, we can see what each icon represents. One is to view its logs, Cs, which only displays about the last 100 lines of logs. If you want to see the complete log, you can download it. The second option allows you to exec into the container to run commands. For example, you can run df to check the mount points, or you can check its CPU usage and collect access logs. When you click here, it starts collecting the JuiceFS access logs, and they begin to refresh in real time. Right. There's also an option to collect its debug info. This corresponds to the FS, and you can check the bugs related to this debug command. We can set it up, for example, to start executing in about 10 seconds, and it will begin collecting some debug information. You can download it and analyze it yourself, or you can hand it over to our team to help analyze the issue. Here, you can specify which letter you want to record for warm-up. If you don't specify, it will just be a warm-up. Gidi or Gwagwaski. The entire file system, ET will start, Gidi executing, and once it's done, that's it. Locally, we have this mixed storage. Another thing is smooth upgrades. After version 1.2.0 in the Community Edition and 5.0 in the Commercial Edition, our CSI supports smooth upgrades. There are two types of safe upgrades. One is a binary upgrade. This binary upgrade only mounts the port without restarting the port. We only upgrade the installation. Click here to upgrade. There's also another option in the upper right corner of the entire pod for a rebuild upgrade. This means it will be deleted and then recreated. During the deletion and recreation process, it will use our latest configuration. The latest configuration up, which is you here. If it detects any changes in the imported configuration, after clicking upgrade on the previous page, the newly created pod will adopt the latest configuration. For example, if you need to change the resources for this pod, you need to increase its CPU memory. After adjusting it on the settings page just now, click upgrade here. This will demonstrate start. Yes, this is the entire auditing process. After the upgrade, it will redirect to the new amount for the page. Of course, I didn't make any configuration changes earlier. Okay, these are the various operations for the mount pod. Now, let me show you how to make a global config modification on the dashboard page. On this settings page, some configurations supported by our global config can be found in this document, which is next to the config. You can click on this link, this little icon, to access it. This document contains all the configurations we fully support. On this settings page, some configurations supported by our global config can be found in this document, which is right next to the config. You can click on this link, this little icon, to access it. This document contains all the configurations that we fully support. Some configuration introductions can also be edited directly by clicking on this editor. We can fill in the information on this Yammer page. If you don't know how to write the configuration format, you can also make changes directly in this graphical interface. This page will first use the PVC selector to find the corresponding configuration. You can find out which mount ports and which PVs it applies to, and which mount ports correspond to these PVs. And this page provides a good display of that. When you hover the mouse over the header, a small tooltip will pop up as a hint. Click on Edit, and you can also see which PVCs this configuration is applied to. Here, we haven't included all the configurations. We've only covered some of the more commonly used configurations, like the image settings for the version of the image. In the commercial version, you can specify which labels and annotations to apply to this mount port, and it also supports setting some environment variables and mount parameters. There are also resource requests and limits that will apply to these PVCs. For example, I add a label ABC to DF. After clicking update here, there will be a second confirmation telling you that this configuration has changed and specifying which PVCs it will affect. After clicking save, these configurations will be updated and take effect. They have been updated, but they haven't taken effect yet because you haven't restarted. If you need to update it on the mount pod, you can click Apply. Clicking Apply will immediately take you to a page for a batch smooth upgrade, informing you that this upgrade will affect these money ports. You can also directly click on this batch upgrade page. And after entering, click the New button to select for a batch upgrade. When creating a new batch upgrade task, you can choose which nodes it will apply to, or select all nodes. You can also specify which PVCs to update. For this upgrade, I will only update this specific PVC. During the entire upgrade process, should I ignore errors and continue updating? Also, regarding the level of the upgrade, after I select these parameters, there will be below is a fact regarding this smooth upgrade. Which pods will I be upgrading? And what configuration changes will these pods have? On the left is its current configuration, and on the right is what you need based on the configuration above. After clicking Start, it will create an upgrade task. And below are some logs related to this upgrade task. You can also click to pause this upgrade task. Clicking pause will only pause the next batch of upgrades. But the current batch is already in progress, so it can't be paused. It's a bit slow, but now everything has been upgraded successfully. Of course, these upgrades are smooth upgrade points. You can click on pause or continue or stop. This batch upgrade has been completed. A bit fast. Okay, this is a batch upgrade. You can see it after the upgrade is completed. It will set an automatic deletion for 7 days for this task. Here is the list page for batch upgrades. Okay, how do we manage the fast cache group on the dashboard? This is a feature of the commercial version for distributed caching. The main focus is on this cache group page. Of course, before using this feature, we need to first install the cache group operator. We can follow the instructions on this page and in the documentation for the upgrade. Go ahead and install the FS operator. This operator is also installed using Helm. I've already prepared its balance point here in YAML. There's nothing special about it. Once the installation is complete, you can just do a one-click install for the film upgrade right after installing. After the installation is complete, you can check the CGCG, which stands for cache group in the user control. I've already created a cache group in advance, but if you need to create a new one, you can click on the create page here. It will give you a simple template. You can also refer to our documentation for the Cascopper operator to change the parameters you need. After clicking create here, you can create a cache group. I've already set one up in advance. We can click in to see the details. Here is the complete YAML for the current cache group. There are several categorical designs in the architecture that you need to consider. Specify which node you want to deploy the cachebook worker on. In my cluster, there are only 2 nodes, so I'll first demonstrate how to remove the worker from this node. It includes a smooth transition where before the worker is removed, the cache from this cache group will be gradually migrated to other nodes, and then the entire worker will exit, ensuring minimal disruption across the nodes. During the migration process, your application will not have cache. Try to ensure your cache hit rate. Here, you can delete it to make the process faster. You can also click here to create a new worker. Once the node is confirmed, it will go to that node to create a worker. After it's created, there will also be a smooth process for gradually building up the cache. I can also click on the quick warm-up option on this cache group page. Okay, the cache is already set up and you can delete it if you want. Yeah, that's pretty much it for this cache group. One more thing to mention is on the details page of our application. Sometimes users are concerned about the pods of my application. Yes, there is a full display of YAML here, which may leak environment variables and other confidential information. Therefore, we have exempted the YAML page on this dashboard. We only display the things that we need to focus on, like the pod, the volumes it is mounted to, and its container. And its status. We've hidden any other information that might involve sensitive data, so you don't have to worry about any information leaks. Okay, on the application details page, there are also some convenient shortcuts. For example, which PVC is this pod mounting? What path is it using inside the container? And is it using a subpath that corresponds to it? A jump to the CCI node of the corresponding base point. This can be seen on the details page. Okay, that's all for the introduction of the entire dashboard. To sum up, the reason why we made such a CSI dashboard is mainly to facilitate everyone. During the process of using SPVC, we can troubleshoot some issues by simplifying the relationships between resources through a graphical interface, making it easier for everyone to make quick navigations. It will also provide some general directions for troubleshooting.